According to the National Electrical Code, it is permissible to combine 277/480 volt cables in the same raceway or enclosure. Section 300.3 C1 states that conductors of different systems, circuits, or voltages shall be permitted in the same enclosure, raceway, or cable if the conductors are separated by a partition, by insulating barriers, or by insulating material. Section 300.3 C2 specifies that conductors operating at more than 600 volts shall be separated from other conductors by partitions, barriers, or other means approved by the authority having jurisdiction. There are several additional considerations to keep in mind when combining 277/480 volt cables in the same raceway or enclosure. Firstly, ensure that the raceway or enclosure has sufficient ampacity to carry the combined load of the 277/480 volt cables. Secondly, use conductors with appropriate insulation ratings for the voltage being carried. Thirdly, provide adequate separation between the cables to prevent electrical interference or short circuits. Fourthly, ground all conductors and equipment properly. Fifthly, clearly identify the different voltage systems within the raceway or enclosure. There are several recommended practices to follow to ensure a safe and effective installation. Maintain a minimum separation of 0.5 inches between the 277/480 volt cables. Use barriers or partitions to separate the cables physically. Install the cables in separate conduits or raceways if possible. Avoid sharp bends or kinks in the cables. Securely terminate and support all conductors. Always consult the local electrical code and obtain a permit before performing any electrical work. Ampacity refers to the current carrying capacity of a conductor. It is the maximum amount of electrical current that a conductor can carry continuously without exceeding its temperature rating. Several factors affect the ampacity of a conductor, including the conductor material, size, insulation type, and ambient temperature. The National Electrical Code provides tables and guidelines for determining the ampacity of conductors in different conditions. Insulation is a non-conductive material that surrounds a conductor to prevent electrical current from flowing outside the intended path. The insulation rating of a conductor indicates the maximum voltage that the insulation can withstand without breaking down. It is essential to use conductors with appropriate insulation ratings for the voltage being carried to prevent electrical shock and fire hazards. Separation between cables is crucial to prevent electrical interference or short circuits. Electrical interference can occur when the electromagnetic fields generated by one cable induce currents in another cable. Short circuits can occur when two or more conductors come into contact with each other, creating a low resistance path for electrical current to flow. Providing adequate separation between cables helps to minimize these risks. Grounding is the process of connecting electrical equipment and conductors to the earth. Grounding provides a low resistance path for fault current to flow back to the source, allowing overcurrent protection devices to trip and energize the circuit. Grounding also helps to reduce the risk of electrical shock by providing a path for stray currents to flow to the earth. Identification of different voltage systems is essential for safety and maintenance purposes. Clearly labeling the different voltage systems within a raceway or enclosure helps to prevent accidental contact with energized conductors and ensures that workers can safely perform maintenance or repairs. Using barriers or partitions to separate cables physically can further enhance safety and prevent electrical interference or short circuits. Barriers and partitions provide a physical barrier between the cables, preventing them from coming into contact with each other. Installing cables in separate conduits or raceways, if possible, is the best way to ensure adequate separation and prevent electrical interference or short circuits. Separate conduits or raceways provide a dedicated path for each cable, eliminating the risk of them coming into contact with each other. Avoiding sharp bends or kinks in the cables helps to prevent damage to the insulation and conductors. Sharp bends or kinks can stress the insulation, making it more susceptible to breakdown. They can also reduce the ampacity of the conductor by restricting airflow and increasing heat buildup. Securely terminating and supporting all conductors ensures that they are properly connected and will not come loose over time. Loose connections can create a fire hazard and can also cause equipment malfunction. Terminating and supporting conductors properly helps to prevent these problems. Local electrical codes may have additional requirements or restrictions for combining 277/480 volt cables in the same raceway or enclosure. It is essential to consult the local electrical code and obtain a permit before performing any electrical work to ensure that you are in compliance with all applicable regulations. A raceway is an enclosed channel designed to hold and protect electrical wires and cables. Common types of raceways include conduits, tubing, and cable trays. An enclosure is a protective housing for electrical equipment such as switches, circuit breakers, and transformers. Enclosures are designed to protect the equipment from environmental factors and to prevent accidental contact with energized parts. The National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment in the United States. The NEC is updated every 3 years and is widely adopted by state and local governments. A permit is a document issued by a local government that authorizes an individual or company to perform electrical work. Permits are typically required for any electrical work that involves alterations to existing wiring or the installation of new wiring. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Overcurrent protection devices trip and de-energize the circuit when the current exceeds a predetermined level. Electrical interference can occur when the electromagnetic fields generated by one electrical circuit induce currents in another circuit. This can cause problems such as noise in audio equipment and data corruption in computer systems. A short circuit is an abnormal condition in an electrical circuit in which current flows through an unintended path with very low impedance. Short circuits can cause damage to equipment and can also create a fire hazard. Ground fault is an unintentional electrical path between a source of current and a grounded surface. Ground faults can cause electrical shock and can also create a fire hazard. Always de-energize electrical circuits before working on them. Use appropriate personal protective equipment such as gloves and safety glasses when working with electricity. Never work on electrical circuits when you are wet or standing in water. Be aware of the potential hazards of electricity and take precautions to avoid them. If you are not comfortable working with electricity, hire a qualified electrician. Remember that electricity can be dangerous and should always be treated with respect. Ignoring safety precautions can lead to serious injury or death. Always follow the instructions provided by the manufacturer of electrical equipment. Do not attempt to repair electrical equipment unless you are qualified to do so. If you are unsure about anything, ask a qualified electrician for assistance. The information provided in this narration is for general informational purposes only and should not be considered as professional advice. Always consult with a qualified electrician before performing any electrical work. The National Electrical Code is a complex document, and it is essential to have a thorough understanding of its requirements before attempting to install or modify electrical wiring. The local electrical code may have additional requirements or restrictions that are not covered in the NEC. It is your responsibility to ensure that all electrical work is performed in compliance with all applicable codes and regulations. Failure to comply with electrical codes and regulations can result in fines, penalties, and even criminal charges. It can also create a dangerous situation that could lead to injury or death. Always take the time to do the job right and to ensure that all electrical work is performed safely and in compliance with all applicable codes and regulations. The use of proper tools and equipment is essential for performing electrical work safely and effectively. Use only tools and equipment that are in good condition and that are designed for the specific task at hand. Inspect tools and equipment before each use to ensure that they are in good working order. Replace any tools or equipment that are damaged or worn. Never use tools or equipment that are not properly grounded. Always use a voltage tester to verify that a circuit is de-energized before working on it. Be sure to test the voltage tester itself before and after testing the circuit to ensure that it is working properly. Double check all connections to ensure that they are tight and secure. Loose connections can create a fire hazard and can also cause equipment malfunction. Use the correct size and type of wire for the application. Using the wrong size or type of wire can overload the circuit and create a fire hazard. Be sure to properly insulate all connections. Exposed conductors can create a shock hazard. Use the correct type of insulation for the application. Follow all manufacturer's instructions for installing and using electrical equipment. Improper installation or use of electrical equipment can create a safety hazard. If you are unsure about anything, ask a qualified electrician for assistance. Remember that electrical work can be dangerous, and it is essential to take all necessary precautions to ensure your safety and the safety of others. By following these safety tips, you can help to prevent electrical accidents and ensure that all electrical work is performed safely and effectively. Always prioritize safety when working with electricity. Your life and the lives of others may depend on it. Do not take shortcuts or cut corners when it comes to electrical safety. It is always better to be safe than sorry. If you are not sure about something, ask a qualified electrician for assistance. There is no shame in admitting that you do not know something. It is better to ask for help than to make a mistake that could have serious consequences. Electrical safety is everyone's responsibility. By working together, we can help to prevent electrical accidents and create a safer environment for everyone. This concludes the discussion on combining 277/480 volt cables in raceways.